If alien civilizations exist somewhere in the cosmos, what would first contact really look like for us? Strip away the Hollywood version. No saucers hovering over the White House. No enlightened visitors handing us an instant utopia. The more likely reality is colder and statistically far more plausible. Our first undeniable sign of intelligence could arrive during a collapse, a final signal thrown into the darkness before everything goes quiet. That idea is the Escation Hypothesis, and it forces us to rethink what detectable really means in the universe. The history of detection bias. To see why the first civilization we detect might already be dying, we need a lesson from astronomy itself: detection bias. Big breakthroughs rarely start with the average case. They start with the weird, extreme, attention-grabbing examples. The ones our instruments can't help but notice. Again and again, what we detect first is not what's most common. Exoplanets are the perfect example. Before anyone confirmed they existed, scientists knew the first discovery would be historic. Teams raced towards it. Many assumed our solar system was a sensible template, so early methods leaned toward finding Jupiter-like planets on wide, distant orbits. But the first confirmed exoplanets, discovered in 1990 by Alexander Volshan, weren't familiar worlds at all. They were strange planets orbiting pulsars, the dead remnants of exploded stars. Then, when exoplanets around normal stars finally appeared, the shock continued. Hot Jupiters, gas giants orbiting 10 times closer to their stars than Mercury orbits our Sun, with temperatures in the thousands of degrees. For decades, the expectation was simple. Gas giants should form far from their stars, where it's cold enough for ices to survive. Yet early detections kept turning up these blistering giants hugging their suns. Here's the twist: hot Jupiters are actually rare. Less than 1% of stars have them. So why did they dominate the early catalog? Because detection bias rewards the obvious. Hot Jupiters are loud. Even when they're uncommon, they're hard to miss. The loudest objects in the universe. One of the clearest demonstrations of detection bias is the night sky. On a dark, clear night, you can see roughly 2,000 to 3,000 stars with the naked eye. And amazingly, about 1/3 of the stars you can't see are giant stars, stars nearing the end of their lives. Our Sun will enter that phase in about 5 billion years, swelling so dramatically it will likely engulf Mercury, Venus, and possibly Earth. Now, notice the mismatch. The giant phase lasts for less than 10% of a star's total lifetime, and only about 1% of all stars in the universe are giants right now. Yet giants make up about 1/3 of what we see. The reason is brightness. Giants are absurdly luminous. Deneb Cygnus is visible even though it's about 2,600 light-years away. Meanwhile, Proxima Centauri, the nearest star to our Sun at just 4.2 light-years away, isn't visible to the naked eye at all. The most dramatic example may be supernovae. When very massive stars, those greater than 8 times our Sun's mass, run out of fuel, gravity finally wins. The star collapses catastrophically. The rebound off the ultra-dense core triggers a violent explosion, and for a few days or weeks, that single dying star can blaze so intensely it outshines the other hundreds of billions of stars in its galaxy combined. Supernovae are rare. A Milky Way-sized galaxy gets about 1 every 50 years or so, yet astronomers spot thousands of them every single year. How? Because they're so bright, we can detect them from essentially the other side of the observable universe, billions of light-years away. History keeps repeating the same lesson. What's easiest to detect is often not typical. It's the loud outlier you can't ignore. The civilization equivalent of a supernova. Extend that logic to alien civilizations. If we ever detect one, the first we notice will probably be unusually loud, not representative, just detectable, which raises a disturbing question. What is the civilization equivalent of a supernova? A supernova isn't normal life, it's disequilibrium, instability. For billions of years, the star was steady and forgettable, with gravity and radiation pressure in balance. It became impossible to miss only when it entered a terminal chaotic phase. Now imagine the same pattern for civilizations. The easiest ones to detect might be those that have fallen out of balance with their planet, civilizations in crisis. That instability could take many forms: sudden urges in energy use, runaway environmental forcing, technological interventions that push a world far from equilibrium, anything that produces outsized waste heat, radiative leakage, dramatic surface modifications, or high-energy transients. One chilling example is something aliens could already notice about us: anthropogenic climate change, unnaturally rapid shifts in temperature, weather patterns, and atmospheric chemistry that simply aren't sustainable on long timescales. At first, this might sound like a clever idea that doesn't change much in practice. But here's where the Escation Hypothesis gets unsettling. The math of detectability rewards loudness. A civilization that is 100 times louder becomes roughly 1,000 times more detectable. That means short-lived catastrophic phases, precisely because they're loud, can dominate what we're likely to notice first. The galaxy could be full of stable, quiet civilizations, and the first one we meet could be a desperate flare right before extinction. The sustainability solution. This connects to an idea in astrobiology sometimes called the sustainability solution. Imagine a thermal image of a housing complex. The bright red patches are waste heat, inefficiency leaking into the environment. Engineers redesigned the system to shrink those leaks. The endgame is a structure so optimized it becomes thermally invisible, indistinguishable from its surroundings with essentially no waste heat signature. Scale that up and civilizations work the same way. The more sustainable a civilization becomes, the less it leaks into space. In a twist on Arthur C. Clarke's famous words, science fiction author Carl Schroeder once suggested that any sufficiently advanced civilization is indistinguishable from nature. Advanced societies could exist right now, and if they solved sustainability, they might blend into the cosmic background so well we'd never notice them. The Escation Hypothesis leans into this. It suggests the civilizations we're most likely to detect aren't the calm, mature ones, but the unstable ones. Even the name hints at the idea, coming from the Greek eskatos, meaning the last, the end of all things. Instability is inherently unsustainable. So if a civilization becomes loudly detectable through disequilibrium, that phase may be brief, because like a supernova, it simply can't last. The nuclear option: maximum detectability. If we're looking for maximum disequilibrium, one scenario sits on the edge of nightmare: nuclear war. If every nuclear weapon on Earth detonated at once, the planet would flare like a cosmic Christmas tree, briefly broadcasting its existence to the entire galaxy. Astronomer James Elliott even suggested doing this in space in 1971 as a way of saying hello to extraterrestrials while simultaneously eliminating Earth's nuclear arsenal. That's maximum volume, maximum detectability, but only for a moment. Exactly what makes it resemble a supernova, a brilliant flash followed by silence. The math matters here. Detectability scales with luminosity to roughly the 3/2 power because observable volume grows as radius cubed. Practically, that means brief catastrophic phases can be wildly overrepresented in what we detect first. The tragedy of first contact. There's a quiet tragedy embedded in this. Pop culture trains us to expect two kinds of alien contact: invaders who come to conquer, or enlightened beings who arrive with wisdom and technology. The Escation Hypothesis points to neither. Instead, first contact could be a civilization in its death throes, broadcasting during collapse, thrashing against the end. It gets darker. A species might realize it's doomed and transmit as a last gamble. Stephen Hawking often warned against broadcasting into space, echoed by the dark forest idea from the Searchin's three-body problem. But if a civilization is dying from within, external threats may no longer matter. When you're facing annihilation, you have nothing left to lose, only the hope that someone, somewhere, might hear you. And then there's the haunting possibility of the WOW signal from 1977, the 72-second burst of radio energy from Sagittarius that was never repeated or explained. What if it wasn't a greeting? What if it was a last cry for help? an electromagnetic scream thrown into the galaxy just before the lights went out. We may never know, but if the Escation Hypothesis is even partly right, it shatters the Hollywood narrative we've clung to for decades. In that version of First Contact, we aren't the victims in a cosmic horror story. We're witnesses, observers hearing the final whisper of a species we never met, whose entire legacy might be a brief signal caught by our telescopes. Not fear, but grief. What this means for the search. In this scenario, we aren't standing helpless before an unknown invader. We're calmly watching the end of someone else's story, the way astronomers watch distant sun-like stars swell into red giants, a preview of our own solar system's fate in 5 billion years. A dying civilization wouldn't just be a discovery. It could be a warning, an echo of what might await any species that can't stabilize its relationship with its world. Of course, there's a critical open question. Are these loud disequilibrium phases common enough and long enough to dominate what we detect? Detection probability depends on three things: the fraction of civilizations that become loud, how detectable they become during that period, and how long the phase lasts. But if the Escation Hypothesis is right, it changes how we should search. We should watch continuously, broadly and deeply for short-lived transients, strange flashes, unexplained bursts, anomalies that appear and vanish. That's the logic behind modern sky surveys like the Vera Rubin Observatory, built to capture video of the entire sky in multiple wavelength bands every single night, hunting for the loud shouts in the cosmic dark. It also widens what SETI can mean. Traditional SETI often focuses on deliberate beacons, civilizations choosing to broadcast. The Escation Hypothesis says, don't listen for greetings, listen for accidents, for unintended leakage, for the electromagnetic death rattles of societies that never wanted to be heard, but became impossible to ignore in their final moments. A sobering possibility. To me, the Escation Hypothesis is one of the most compelling angles on the Fermi paradox. It offers a reason the universe seems silent even if intelligent life is common. Stable, sustainable civilizations become effectively invisible, while unstable ones flare briefly and then disappear. Consider the scale. If even a small percentage of the estimated 100 to 400 billion stars in our galaxy host technological civilizations at some point, the sky should be alive with signals. Yet, in over 60 years of searching, we found nothing definitive. The Escation Hypothesis offers a clean explanation. The civilizations that endure learn to blend in. The civilizations we notice are the ones in crisis, and the crises don't last long on astronomical timescales. I'm not claiming this is proven, but the pattern from astronomy is hard to ignore. Hot Jupiters, giant stars, supernovae. Over and over, what we detect first are the loud freaks, the extreme outliers, never the quiet majority. Why would alien civilizations be any different? So maybe our first contact with aliens really will be their last words. A final transmission from a species that burned too bright, consumed too much, and tipped itself into collapse. And maybe the most important part of that message wouldn't be about them at all. Maybe it would be about us. A warning from across the stars, showing where unsustainable paths ultimately lead. The only question is whether we'll be wise enough to listen. So there you have it. The Escation Hypothesis suggests our first contact with aliens will be a civilization's final scream into the void. But speaking of cosmic journeys, have you ever wondered how long it would actually take to reach the other planets in our solar system? Check out my video on how long it would take to reach every planet in the solar system, where we break down the travel times to the solar system planets and beyond. The distances involved are absolutely mind-bending.